And the first objective, honestly, can be largely done on your calculator, ladies. But I hope that when you look at these, you're thinking about why the answers might be what they are, okay? Because I don't know if this ever happens to you, but I've typed things into my calculator wrong, written it down, moved on, and then been really mad at myself when I got my test back, and it was just a calculator typing error, okay? So when you see, number 1, evaluate 36/25 to the negative half, okay? Again, it's a math teacher's hope that you think, this is my thought, okay? Hey, that's a negative exponent, and negative exponents flip things over, okay? So that would be like 25/36 to the half power. And I didn't make my thought bubble big enough, but when you raise something to the half power, that's like doing what else? Square rooting, right? So raising something to the half power, continued thought bubble, is like square rooting 25/36. And so I should write down the exact answer of 5/6. Okay. But again, it doesn't have to go all on in your head. It can go on in your calculator. Please make sure that your calculator will give you that answer because it is the right answer. All right, again, you know, your calculator, it can't read your mind, so we've got to put parentheses in the right place and all of that. So I just typed in this original, okay, 36/25 to the power of parentheses around a fractional power, negative 1/2. It gave me this crazy decimal. If I want an exact answer, I'd prefer that in fraction form. Okay. All right, again, just kind of thinking what goes on here. Now, this one, number 2. Log base 9 of 5. Again, my hope is that you're thinking, what power of 9 is equal to 5? Okay, because that's the question we're answering here. But I know it's not 9 to the first because that's 9, and 9 squared is 81. I'm going the wrong direction. So again, I'm thinking it's between 9 to the 0 power is 1, and 9 to the first is 9. So I'm thinking my power's got to be between 0 and 1. Okay. We talked about lots of ways to solve this. Graphing, trial and error. I don't like trial and error. So I'm going to type this in using the change base theorem. Okay? Remember that sheet of million chapter 6 formulas that you have? By the way, you will be able to have that sheet right by you for the test. But you can't have any examples on it or anything. It'll have to be the bare naked sheet that I gave you. Okay? You can still have a sheet back here with other stuff on it if you want, help sheet. All right? So I would type this in as the log of 5 divided by the log of 9. Okay. You got to remember that when your calculator, when you type a log, your calculator gives you a parenthesis. You have to close that one, or it's going to mess it up. Okay. And then we're rounding. Okay. We do know how to round. We just sometimes forget to. Okay. Decide what would be a good answer for 2. What would be the correct answer for 2? 0.73. Okay. Again, I'm giving you rounding directions. We do want to look at the 2 next to the, tenths, hundredths, thousandths. Look at the thousandths place and say, hey, that's only a 2, so that just stays. All right. 5 or more round up. Again, for number 3, I'm hoping you're thinking 9 to what power equals 1/27th. But again, I know that 9 to the first is 9, and 9 squared is 81. And how do I get 1 over that? And how do I make it 27? Okay. Again, I'm thinking that if it's going on the bottom, it's got to be a negative power, right? That's what we were talking about up here. Negative powers make things go in the denominator. So again, I should be able to type that in with the change base theorem like this. Log of 1/27th divided by log of 9. Okay. Go ahead and do that. Again, looking for an exact answer. And negative 1.5 or negative 3/2, both of those would be exact. You don't have to put it as a fraction, but you could. And then in number 4, okay, we've got a e to the natural log of something raised to a power. Okay. Again, I will talk about the thought process that goes into that after you see if you can type it into your calculator correctly. Again, this could purely be a calculator one. I'm going to show you what the thought process looks like after we agree on an answer. So please type that in. Okay, careful with parentheses and stuff, and see if you can come up with the same answer as the person next to you. And the correct answer is 0.25, or I think I heard someone call it 1/4, which it can also be called. Okay, let me show you first of all how I typed that. Okay, initial parenthesis and then a power, and if this is all in the power, I got to put that in parentheses. Okay, and here I'm closing my parenthesis for the 16, I'm closing my parenthesis for the power, and I'm closing the parenthesis I started with. Okay, can drive you nuts. You guys probably have nightmares about parentheses. Okay, all raised to the power of parenthesis negative 1/6. Okay, so again, it always makes me upset if I get something wrong because I typed it in my calculator wrong. So let's talk about why this is 1/4. Okay, I'm going to do something with this power that we were working on pretty hard the last couple of days. Again, and you can just watch this. I definitely would type this in my calculator even if my math teacher wanted me to think about it. All right. So this would be e to the natural log of 16 cubed. And then negative 1/6. So you know how we've talked about how that number in front can go back to the power? Okay. Well, 16 cubed is a really big number, but whenever I raise e to a natural log or the natural log and raise that to the e, these cancel each other out. So this would just give me 16 to the 3rd. And I could multiply out 16 to the 3rd, but I don't want to because that's a really big number, and I just wouldn't be able to do that without my calculator. So I'm going to use one of our other properties on our formula sheet. When you raise a power to a power, you what the powers? Multiply the powers. So that would be, what would that be reduced? Negative 1/2? Now up here, remember when we had that negative 1/2 power and I said, hey, flip it over, make it positive? Well, remember that when you flip over 16, you would get 1/16 to the 1/2 power. And then 1/2 powering is the same as square rooting. And the square root of 1 is 1, and the square root of 16 is 4, and 1/4 is 0.25. All right, and I noticed I grabbed another piece of paper because there's no way I was fitting that all in wherever I was trying to fit it, okay? All right, let's try 5. 5 on a calculator with a change base theorem, and then we'll talk about 5. You know, what would we do, or what would our thought process look like without a calculator?